The year 2026 emerges on the horizon of astronomy, not just as a date on the calendar, but as a possible historic turning point for our solar system and its most controversial sun. Renowned scientists from various global institutions are returning to officially discuss the reclassification of Pluto as a full planet, reigniting a debate that many considered closed forever. The debate that seemed buried in the pages of textbooks since 2006 has been reopened with unprecedented energy, driven by new and robust geophysical analyses that challenge old conventions. The rigid and purely dynamic definitions of modern astronomy are being tested by a new generation of researchers who look at geology as the primary determining factor for a world. For 2 decades, we were taught to recite that the solar system has only 8 official planets, a list that systematically excluded the frozen and mysterious world orbiting in the darkness. But this distant world never silently accepted its bureaucratic demotion to the category of a dwarf planet. And now, science itself seems to be changing its mind about this small giant. Pluto inhabits a cosmic frontier region, a realm of eternal cold and deep shadows that exists far beyond the majestic orbit of the gas giant Neptune at the edge of space. In this remote region, known as the Kuiper Belt, Pluto reigns as one of the largest celestial bodies, surrounded by countless frozen objects left over from the solar system's birth. In 2006, a historic administrative decision drastically changed Pluto's fate for humanity when the International Astronomical Union, the IAU, decided to rewrite the rules of the planetary game. The IAU established 3 fundamental criteria for a celestial object to hold the title of a planet, but the third point became the Great Wall for the frozen world of Pluto. An object must orbit the Sun independently and have enough mass for its own gravity to mold it into a nearly spherical shape, requirements that Pluto fulfills with absolute excellence. The great controversy that persists today lies in the bureaucratic requirement that the supposed planet must have cleared its own orbit, gravitationally dominating its entire trajectory through the deep space. Pluto shares its orbital region with billions of frozen bodies and comets, which, according to the 2006 definition, would automatically disqualify it from the status of a primary planet. However, the geophysical and atmospheric complexity revealed by recent space missions is so vast that ignoring Pluto's planetary status seems more and more like a glaring and major historical error. New high-end scientific studies, published by international teams of researchers, argue that the definition of a planet should be based intrinsically on what the object is, not where it resides. This new school of geocentric thought argues that active geology and internal structure are the true hallmarks of identity for a world that deserves to be called a full planet. The discovery of Eris in 2005 was the original trigger for the dramatic change, as it had dimensions very comparable to Pluto, creating a fear of having hundreds of official planets. To avoid this scenario of administrative and educational complexity, astronomers created the category of dwarf planet, a solution that now, in 2026, is being severely and formally questioned. The current scientific movement, led by heavyweights in space exploration, proposes that any spherical body with complex geology must be recognized as a planet by its own rightful merit. Elite planetary scientists, many directly linked to NASA's New Horizons mission, form the vanguard of this resistance movement seeking cosmic justice for the small world of Pluto. They vehemently state that the current IAU classification ignores the most fundamental and fascinating characteristics of a living world, focusing only on simple, dynamic, and orbital aspects. The New Horizons mission was the true historic turning point, revealing to humanity in 2015 that Pluto is not a dead, frozen rock on the outskirts of our solar system, The probe revealed a vibrant world with active internal processes that defy all the predictions and theories that existed before the historic flyby carried out by the robotic spacecraft. Before this epic mission, we saw Pluto only as a blurry dot of light in the largest telescopes, but New Horizons showed us landscapes of staggering and impressive beauty. The probe gifted us with images of majestic water ice mountains that rival the largest mountain ranges on Earth, and vast nitrogen plains in constant and rhythmic movement. The region of Sputnik Planitia, Pluto's famous geological heart, became incontestable proof that internal heat and geological activity pulse under the frozen crust of this distant and mysterious world. This vast plain of ice has no visible impact craters, indicating to planetary geologists that its surface is extremely young and is being constantly renewed by internal heat processes. Recent studies suggest that this surface renewal might be driven by a subsurface liquid water ocean, kept warm by the residual heat from Pluto's rocky and ancient core. The presence of a subterranean ocean in a world so far from the Sun would fundamentally change our understanding of where life can potentially exist in the vast and deep universe. Water ice mountains reaching kilometers in height demonstrate that Pluto has a robust and complex structure, with a crust capable of supporting impressive and very varied topographies. Even with surface temperatures reaching 220 degrees Celsius below zero, Pluto maintains a thin atmosphere that breathes and interacts dynamically with the frozen and cold surface. This atmosphere is mainly composed of nitrogen, methane, and carbon monoxide, creating complex hazes and misty layers that protect and sculpt the unique landscape of this distant world. Pluto's moon system is another powerful evidence of its complexity and gravitational influence, with Charon being so massive that the pair forms a unique binary system in the solar system. Charon is about half the size of Pluto, creating a gravitational embrace so strong that both worlds orbit a point in space located outside Pluto's actual physical surface. In addition to the large and mysterious Charon, the four small moons, Styx, Nix, Kerberos, and Hydra, form an intricate and chaotic orbital ballet around the central pair of binary worlds. The complexity of this satellite system suggests a violent past and a dynamic evolution that rivals that of the giant gas planets in our own diverse solar system. The scientific movement gaining strength in 2026 proposes a geophysical definition of a planet, focusing on the intrinsic physical properties of the object rather than its current orbital neighborhood. Under this new proposed definition, Pluto would immediately regain its full planet status, and the solar system would once again have 9 or even more officially recognized primary planets. Many educators, science communicators, and astronomers have already returned to using the term planet to refer to Pluto in recent conferences and publications, anticipating a possible official change. Ongoing space exploration is proving that the boundaries between what is a planet and what is not are much more fluid and complex than we previously thought. Each new piece of data analyzed by modern supercomputers reinforces the idea that Pluto has a geological personality and complexity that exceeds many other known celestial worlds. The debate intensifying in 2026 is not just about a name or a bureaucratic classification, but about how we understand the complexity of the universe and its many worlds. Scientists argue that labeling Pluto as a simple dwarf planet diminishes its scientific importance and discourages public interest and funding for future and necessary exploration missions. Pluto remains an invaluable natural laboratory for the study of complex organic chemistry and the formation of exotic ices that do not exist anywhere else accessible to us. Its reddish surface is rich in tholins, complex organic compounds formed by the irradiation of methane and nitrogen, which are fundamental building blocks for the chemistry of life. Understanding these chemical processes on Pluto could provide crucial clues about the origins of life on Earth and the possibility of life on other frozen and distant worlds. Regardless of the final IAU decision, Pluto remains one of the most coveted destinations for future robotic space missions that will search for signs of life or internal oceans. Scientists are already designing conceptual missions that could orbit Pluto for years, mapping its surface with even greater detail and studying its atmosphere and moons in great depth. The story of this small frozen world teaches us that science is a living and dynamic process, where yesterday's truths can be questioned and reformulated given new evidence. Pluto's journey reflects our own evolution as an exploring species, trying to bring order to the chaos of the cosmos while marveling at its indescribable and vast beauty. In the frozen and distant horizon of the Kuiper Belt, Pluto's nitrogen heart beats silently, waiting for the day it will again be recognized as a solar system pillar. Pluto's resistance to fitting into simple categories challenges our human need to label and compartmentalize the complexity of the universe that surrounds us every single day. May this triumphant return to the scientific agenda in 2026 inspire us to look at the sky with more humility and an open mind for the surprises the cosmos holds. Pluto's official fate is being written right now in research labs and observatories around the globe, where the passion for knowledge overcomes static and old definitions. We anxiously follow every new discovery and scientific debate, knowing that the universe always reserves the last word for those who have the courage to observe the stars. The small ice giant continues its solitary and majestic walk around the sun, indifferent to human labels and debates, but carrying the deepest secrets of our cosmic origin. Its geophysical complexity is a testament to the diversity and wonder that permeate the cosmos, challenging us to expand our minds and our definitions of what is truly possible. May Pluto's story serve as a constant reminder that space exploration and the pursuit of knowledge are continuous and endless journeys, full of surprises and major turns. Pluto's heart continues to pulse in the darkness, a beacon of mystery and discovery that draws us to the frontiers of our knowledge and our understanding of the universe. In every image, in every piece of data, in every debate, Pluto invites us to question what we know and to imagine what is yet to come in our search. In this eternal dance between the pale light of the distant sun and the deep shadow of the Kuiper Belt, Pluto's geological heart remains as a beacon of mystery at the frontiers of our cosmic knowledge. If you believe that this magnificent and complex world deserves to regain its throne as the 9th planet of our solar system, subscribe to the channel so you don't miss any chapter of this space saga, and leave your comment about what you think of this possible triumphant return in 2026.